Greg Weinsteiner, Seth Long, Robert Cooley, Nathan Ferrer, and Jeff Edwards. The main goal of our project was to address a fundamental need in giving people wireless control of their home electronics. And the way we started this is we first did research on existing market technologies. From that research, we noticed that an area of improvement would be the range in which these systems operate. We decided to improve this range by combining GSM with ZigBee, which would allow us to control these electronics with SMS text messages. So the way this could be useful is, for example, if you arrive at work and you realize that you may have forgotten to close your garage door, this system would allow you to perform a status check using your cell phone while at work, and in the event that the door is open, it would allow you to close it while at work just using your cell phone.
So the first semester using our Arduino Uno for our proof of concept, we were able to get the ZigBee and GSM module communication going, turning on and off some relays. This semester we went ahead and moved forward to a Beagle bone micro single board computer, so we could expand it, limited memory on it, limited amount of code we put in there, and what we could do with it. And first semester we just sent out a multicast message to our ZigBee because we only had one of them, and this semester we have multiple ZigBees. We're using the full 64-bit address so that we can connect a good number of devices. The ZigBees are very useful because they have a range of the low-end models that go up to about 100 to 300 feet, depending on indoor and outdoor, or ones that go over a kilometer. The devices we control are a coffee maker, so you can turn that on or off, and you can also, whenever you turn it on, it'll tell you when the coffee, you can send you a message back saying that the coffee is ready. You can also send a delay saying, turn on my coffee in 8 hours, or turn on my coffee in 4 hours. With the garage door, not only does it have a sensor to let you know the garage door is open, but also has the capability to take a photo so you can have visual confirmation. And we also added to our relays where we're turning on and off devices. The ZigBee modules have built-in ADC, digital I/O, and postal modification, so there's almost anything we can control with this without having a microcontroller at the device that we're using. We added that so we could have current sensing, so we can calculate power usage on these relays, so you can actually see how much power you're using on the devices. Any questions?
I understand the concept, but a lot of things now you can't just turn on. The coffee pot no longer is just you turn it on and it starts brewing. It's, you turn it on after two spots and whatnot. So how does that all happen versus?
We've actually wired into the coffee maker that we use for our demonstration and took over the button, and so we're closing that relay, so we're actually turning it on, and then we're able to also turn it off by releasing that. And then as for the user interface, it's just you can either do the complex text messages you don't recommend, or last semester we built an app so you can just push buttons on your phone, turn things on and off, and it gives you an indicator of whether or not they're on or off. Devices that can't be controlled just by simple on and on. We have digital I/O with the low voltage relays, so we can send on and off signals. We also have the high voltage relays, so we can turn on and off devices up to 220 volts. And then also it has serial communication, so there's a device that has serial communication for, we can do that. Also, which means you can extend it to infrared devices. So it really is pretty close to limitless as long as there's a way to control the device.
Let's say I turn my toaster on or my oven, and then I lose cell phone connection. Will it turn off after a period of time, or will it just stay on?
Right, yes. Right now, the coffee maker for our demonstration, we've shrunk the time down a lot. So whenever you turn on the coffee maker, it waits 2 seconds and says, okay, your coffee's ready, and then 2 seconds later it goes ahead and turns it off. we also implemented some security so you can lock the device, only work for one phone. This device is currently, has a hard code in mine, so mine can't be locked out, but any person can send and control it unless the device has been locked. Once it's been locked by a device, no other device can control it.
Did you research commercial systems that were available?
We did, and the common theme that we found is a lot of them run on Wi-Fi and they don't have the range. So like, if you use text messages and SMS, I mean, you could be halfway around the world and, you know, check the state of your garage door.
All of these devices have gateways. So did you research things like Instant or Razia?
We did, this is our second semester. We did in the first semester, and what we did is we kind of compared them all, you know, what we liked in the strengths and the weaknesses, and then the common weakness that we found was that range, and that's really what we tried to improve upon.
The range inside the home.
Well, outside of the home as well, because we wanted you to be able to control your devices while not away from home, like the example I gave. And then something that I didn't mention in terms of the power management, we wanted to go into a system where it would be able to read the variable rates from an electricity company, and you could program it to run your high energy appliances when costs are lowest. So the defrost cycle on your refrigerator, that would run at like 3 a.m. when the rates are down, as opposed to peak hours, you know, 7 a.m.